have decimal answer. So 9 squared is 81, and that's 144. And 81 plus 144 is 225 square root. So that is R. R is square root of 225. So now I can write my primary trig ratios, but now we have 6 trig ratios. So how do I write the sig trig ratios? Easy. You first write your initial 3, your sine theta, your cos theta, and your tan theta. You always write your initial 3. And I'm saying theta, but yeah, I should probably write beta, I guess, technically, since it doesn't really matter what the question is asking, I guess. You could label it whatever you want, but we should follow proper, I guess, symbols and terminologies. All right, sine beta is equal to. Wait, do they want beta or do they want theta? I'm curious now. No, they do want theta. Oh, yeah, see, that's why I was actually interested to see which one they wanted. So they do want theta. Yes, that's what I thought. All right. Because normally whenever they're asking, they're usually always asking for theta anyways. All right. So sine of theta. Well, what's the difference between sine of theta and sine of beta? There's really not much difference. And I'll show you that right now. So sine of beta is opposite, which is 12 over hypotenuse. So 12 over square root 225. And the only difference between beta and theta is the positive and negative sign. So you have to use cast rule to figure out, is sine supposed to be positive in this quadrant or not? And since this is the second quadrant, sine is supposed to be positive in this quadrant. So what I'm going to do is, I'm actually going to make myself some more space, because I didn't leave myself space here. I'm going to do cos theta now. Cos theta is adjacent, which is 9 over square root 225. But hold on, use the cast rule to figure out, in this quadrant, is cos negative positive? And cos to negative, so the final answer has to be negative 9 over square root 225. And then tan theta is opposite, which is 12, over adjacent, which is 9. And tan is actually negative in this quadrant, so it's negative 12 over 9. So these are primary trig ratios. So far, nothing new. But now I'm going to write my, should have left myself more room, but that's okay. I'm going to write my reciprocal trig functions, or trig ratios. So now I have cosecant, which is the opposite of sine. So that's going to be root 225 over 12. And all I'm doing is I'm just flipping the fraction. Secant, which is the opposite of cos, and I'm just flipping the fraction. Doesn't really matter where you're at the negative sign. You can write it on the 9 or the top numerator. It doesn't really matter. And then we have cotangent, which is the opposite of this guy here, which is 9 on top, 12 on bottom, and the negative sign is there. And that's the answer. That's it. That's all you have to do. So don't be confused just because there's 3 new ratios now on the block. Oh, I didn't even realize, but square root 225 is actually 15. I didn't even check. That was my fault. I didn't even check to see that that gives us a whole number. So we don't have to write that. We can just write 15. So that was my mistake. I didn't use a calculator. I assumed it wasn't a perfect square, but you're right. It is 15. So this is just 15, 15, 15. So yeah, always actually check to see if you get a whole number or not. That's a good lesson to learn. All right, so there you go. That's the final answer. And we have time enough for one more, possibly. Yeah, one more. And then we're done. Here we have an equation cosecant theta plus 2 equals 0. So cosecant theta is equal to, bring the 2 over, negative 2. Remember, always write it in terms of fractions, so it's easy for you to flip it. So if I know that cosecant theta is negative 2 over 1, I know that cosecant is the flip or the reciprocal of sine. So I know that sine theta is going to equal negative 1 over 2, right? Because remember, they're the flip of one another. So now I can solve it, because I know how to solve for sine. I know that I can just do theta is equal to the inverse sine of negative 1 over 2. And let's do that. What do you get when you do that? Let's see, what do we get? 2, negative, shift, sine. We get negative 30 degrees. Now, negative 30, I can't draw that anywhere, because we start from 0 and go into the positive realm. So guess what? I gotta do that trick of adding 360 to it. And if I do that correctly, theta is equal to 330 degrees. So now I know my terminal arm has to be here. And I know that this is 330 degrees. That means I know the angle inside my triangle is 30 degrees. All right, so the angle inside is 30 degrees. Perfect. We got an answer. Are we done? No, we're not done. Because we can have multiple answers. Remember, you can have at least 2. So this was sine. And we know sine is negative. So which quadrant is sine going to be negative in? Let's find out. Well, I know it's negative here in quadrant 4. It's not negative in quadrant 1 because everything's positive. Since this is sine is positive here. So it has to be in quadrant 3 now. My second triangle. Or terminal arm, I should say. So yeah, let's do that. Let's draw this now. Let's figure it out. I know the angle inside my triangle is the same as the angle here. So this has to be 30 degrees. And then I know the angle from here to here is greater than 180. And exactly 30 degrees greater than 180. So I'm going to just do 180 plus 30 degrees. And I'll get 210 degrees. And you can check that in your answer. You can just sine of 330 and sine of 210, and you should get negative half. And that's the answer. So that's how you solve something like this. 3 centimeters. Perfect.